Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 783 that says minimum distance between BST nodes. So here we are given a tree with a root node. So in this array represents the tree and we need to find the minimum difference between any two different nodes in a tree. So you can take any two nodes like 4, 2, 4, 6, 4, 3, 4, 1 such that the difference between them is minimum. So as you can see here in this example 1, the difference between 1 and 2 is 1, 2 and 3 is 1, 3 and this 4 is also 1. So yeah, the minimum difference here is 1, so we return 1 as our answer. In the second example, as you can see, the difference between 1 and 0 is 1. Yeah, all other differences are greater than 1, like difference between 12 and 1, 12 and 48. So yeah, 1 is our answer, as the difference between 0 and 1 is the minimum here. So I hope you guys understood the question. Yeah, the question is pretty much simple, that you need to find the difference between any two nodes. It can be any nodes. Okay. So also there is one similar question as they have noted here, and also note that there are 10 raised to 5 node dot 12 means each value can be, and total number of nodes range between 2 and 100. So yeah, there are not many nodes here, as you can see, at max 100 nodes only. So let's take these as our example. So here you have this type of tree. See, first thing that you need to note here is the given tree is what? The given tree is binary search tree. Okay, keep this in mind, that the given tree is binary search tree. So one way to solve this question is you can use a vector and store what? Store all the values, like store all the values in order traversal. So what, say, one thing is to note here is in order traversal would be sorted, right? This is the property of binary search tree, that if we do in order traversal, then it will give sorted result. Like the in order traversal here is 2, 6, 14, 16, 19, 22, 25. See, this is the in order traversal. Okay, and this will give us this will be always sorted. So yeah, if we do in order traversal and we store all the nodes in the vector like 2, 6, 14, 16, 19, 22, 25, this is one way. We keep storing all the values of the nodes in a vector, and then afterwards we will take the adjacent difference. Why only adjacent? Because the tree, this vector is already sorted. Yeah, so yes, we can take adjacent nodes and take its difference, like this difference d1, d2, d3, and choose the minimum difference among all. Choose the minimum difference. Got it? So yeah, this is one way to solve this question, right? To store all the nodes values in a vector and then take the difference, and we return the minimum difference as our answer. But we won't do this. See, this is space consuming. This will consume big O of n space. For n nodes, it will consume big O of n space. So should we do this? No, we should not do this, because the given tree is binary search tree. Its pre-order traverse will it will itself give a sorted result. Correct? So yeah, storing these won't be means is of no point. We can already traverse it in a sorted manner, and yeah, we can take the difference. Difference is simply the previous minus the current node. This is previous minus current, because it is already sorted. Correct? So yeah, we will do that same thing that we will do in order traversal, and we will take the difference. So yeah, what is in order traversal? So in order traversal, if let me write down here, in order traversal is left, then process node, that means either print or store what you want to do, and move to right. So this is in order traversal. Okay, this is how in order traversal works. Like we move to the left child up till all the left child is possible, then we process the node, then we move towards the right child. Simple as it is. So yeah, based on this in order traversal, now we will compute our answer. So yeah, I told what was the first step of the in order traversal? Left. So we keep moving to left. From here to here we move from here to here. From here, left is possible? No. Whenever left is not possible, we will process the node. Okay, so here we are there. Now what does it means to process the node? See, here the process means either to take a subtraction, means take a difference with the previous node, right? What in order here to process node means difference between previous and current. So this is what we meant here to process the node. Okay, But when you come here, the previous node means we haven't stored any node till now as a previous node. Okay, so here at this point previous would be null, right? Previous would be null. So yeah, there is nothing like previous here. So we move back, but while moving back we make previous as 2. So for these 6 we get previous as 2 and current node as 6. Okay, so here the previous is not null. See, initially for this node there was nothing as in the previous was null, but while moving backwards we make 2 as our previous. Got it? Clear till now? We make 2 as our previous. So for this 6 as a current node, the previous is 2 and we took the difference. The difference is 4. How much? 4. Okay, so for better understanding, let me erase this and write things here. Let me just erase something, these things out, and let me write here. Okay, let me write is previous node and current node. So previous node was null when current was 2. Node was 2, then previous was null. Now when current node is 6, then previous is 2. We are traversing backwards. At that time we make 2 as our previous node. Correct? Now we took the difference. Here the difference here the difference was max. Here the difference was 4. Okay, 6 minus 2 is 4. Correct? Now what we are doing from here, we are traversing to node 14. Okay, so let me do this. So when we traverse the node 14, 6 was the previous node. Correct? So we took the difference, but is difference greater than 4? No, so we keep 4 as our difference, right? Now after 14, as you can see, in order traverse there is nothing, right? So we directly move towards what? Towards the root, that is 16. So when the current node was 16, our previous node was what? It was 14. See, from 14 we move to 16. As you can see, in order traversal, that way in order traversal works. So yeah, here the difference become 2. Correct? Now we traverse to 22. Okay, we traverse to 22, then 22 to 19. Okay, now when we come to 19, our previous was 16. See, when the current node was 19, the previous was what? 16. We took the difference. The difference is 3, so we don't need to update it. Now see, this was the previous node. You can think like that. We directly after 16 we directly move to 19. So this is how the in order traversal work. Okay, then we take the difference of from 19 we traverse back to 22. Okay, now the current node is 22, and so for that the previous node is what? 19. From 19 we are traversing to 22. Okay, so we make previous as 19. So 19 minus 22 is how much? It's also 3. So we don't update it. Then what we are doing? We are moving to 25, and its previous is 22, because from 22 we are moving to 25, right? And the difference is how much? The difference is 3, so we don't update it. Simple as it is. Yeah, and now everything is every node is visited. Now after this we would simply end. Okay, so as you can see that we got 2 as our answer. The 2 is the difference between this 14 and 16. So yeah, I hope you guys understood that how this in order traversal works. By in order traversing, we can process the node, and as well as while processing we will update the difference. Simple as it is. So yeah, now let me show you the coding part here. So yeah, this is the code for the solution. So here we are keeping one previous node, and this is simple in order traversal. In order traversal, like left, then process the node, update the previous node, and then move towards the right. Simple as it is. Okay, now let me try to explain you this thing with an example. So let me draw one graph here. So let us take some so let me draw one graph here. Let me make a bit simple graph. 16, let me keep here as 6, let me take here as 22, and here let me take as 19. Okay, so yeah, this is the given tree that we have right now. Okay, and now what we want to do is we want to find the minimum difference. So yeah, for finding the minimum difference, this is our code. Now let us try to traverse, means do a dry run for this code. So initially the previous was null, so let me write down previous, and here current. C for current, P for previous. Okay, and yeah, we started with answer equal to int max. This is how we initialize the answer, and we took n% here so that we don't make any copy. Okay, so yeah, for that reason we are doing that. Now yeah, here we call on root this solve function. The solve function is called. So what does this solve function does is it move towards the leftmost node. Means if the root of left is there, then move towards the left. If again left is there, then it will move towards the left. Means it will move towards, means if there were many nodes here, then it will move towards the leftmost node. Okay. Now once you reach this end, so here this is the end, it moves towards from here to here. So this was the end here. So let me take one another color. Okay. So here this move from here to here, right? 16 to 6. This is the leftmost node. So once you move to a leftmost node, so initially if for the node 6 the previous is null, like previous is null, and the current node is 6. So here our answer would still remain the max. Okay, got it. When you revisited this node, now you are trying to get move towards the right. As you can see here, move towards the right. There is nothing right. If there is nothing right, then we return. Okay, we return again back to 6 to 16, correct. Now here on returning, what we are doing, we are visiting what? We are visiting node number 6 with the previous node of 6. We are visiting 16 by the previous node is 6. Okay, now here the difference become 10, right? It is better than this max value, so we updated this. Now from here 16, what we are doing, we are moving from 16 to 16 towards the 16. So 16 is our node, current node, and now we are moving towards the right because there is nothing in the left. Okay, but since before moving towards the right, we are moving previous as a root. So for any further node, the 16 would be previous. Okay, this we are doing, then we are moving right. Okay, so here we are moving right, 16 to 22. Then after we move towards right, we saw that there is something on the left, so we move from 22 to 19. Okay, now there is nothing on left and right, so our current node becomes 19. But for this 19, the previous would be 16 as it is, because we moved towards the right and towards the left. Then we didn't encounter this situation where we updated the root. So where we updated the previous, so our previous for this 19 would remain 16 as it is. And here, as you can see, the difference would be 16 minus 19, that is 3. And yeah, now we are moving backwards. We are moving backwards to 22. The difference between 19 and 22 is how much? So for the current node 22, the 19 was previous and is also 3. Okay. And yeah, from the 22 we are moving back to its root node. So let's say, so means if the no current node is 16, then its previous node was 22. The absolute difference would be how much? Would be greater than 3, right? It would be 6, so we'll keep 3 as our answer. So yeah, for this tree we would get 3 as our answer. And I hope you guys understood the diagram that we are moving towards the leftmost node, then afterwards we are processing the node, and then we are trying to move the rightmost node. Okay, so and after rightmost we are again moving to leftmost, right? After the rightmost node we are again moving to leftmost. So in between we are not doing this, so from this to directly this, right? This is how this code works. So I hope you guys understood the dry run approach for this. And here also and here we are not taking any extra vector or using extra space, just this DFS call. This is simply DFS, so it will use stack, inner stack, to store this root node, correct, and also the answer. So yeah, I hope you guys understood the question, the approach, as well as the code for this. And now talking about the time and space complexity, the time complexity here would be big of n, as we are traversing all the nodes, and space complexity would be also big of n, because the inner stack of this DFS would store n nodes. It will be surely less than n. It will depends on the height of the tree, but yeah, in the worst case it will take big of n nodes. So yeah, that's all for this video. Make sure, and if you have any doubts, then do let me know in the comment section. Make sure to like this video and subscribe to our channel. Thank you.